All right, chemistry students, I don't have the slides up here because I want to introduce functional groups with some white space, okay? So we'll go to the slides in a little bit, but this is the second video for Chapter 12, the organic chemistry, okay? So organic chem. All right, so the last video focused on hydrocarbons, alkanes, alkenes, alkynes, and I didn't actually define aromatic. But if you remember, I was saying at the very beginning, it could be something that, like if you took six carbons and you actually made it into a circle and connected them, then you would have aromatic substances. And because they're connected around, you would vary the number of hydrogens, okay? So each carbon in this aromatic alkane would contain 2 hydrogens, okay, in order to satisfy the octet. But I did not define that on the last video. I do want to get into functional groups. So let's draw a plain, we're just going to start with a plain alkane. And I'm going to just draw 5 carbons, okay? And what you're going to do, if you're like, I still don't really know what a functional group is, we will define it on the slides. But what we're going to do, instead of having all hydrogen, so this very last carbon, what I'm going to do, I'm going to actually change my color to red to really emphasize this, okay, is instead of making it a hydrogen, let's just make it an oxygen bound to a hydrogen, okay? And I'm going to draw my lone pairs on the oxygen to make it super duper clear, okay? So we are replacing the hydrogen with a certain component. In this case, this component is called an alcohol. So it's an alcohol group. It's an example of a functional group. So it is a functional group. So you can say is a functional group, okay? And it doesn't matter what this alcohol is attached to in terms of, in this case, we've got 1, 2, 3, 4, 5 carbons. In general, the alcohol functional group has certain properties among organic substances. So if I just had the alcohol functional group, we'll draw the condensed for 3 carbons, okay? So I'll draw these hydrogens out. If I just have this condensed with my lone pairs, that would still have the same properties as the first one I drew. It just might differ a little bit. But because both of them contain a hydrocarbon organic substance with an alcohol functional group, they would have similar properties. So both of these substances could be categorized into the properties of the alcohol functional group, okay? So organic substances are definitely characterized by their functional groups, and there are about a dozen different functional groups that you're going to need to memorize. So just memorizing OH is the alcohol group is 1, okay? And recognizing the OH, and there's nothing else, the rest of it is hydrocarbon, is you're going to need to recognize that. Now whether you draw it like the first one, the second one, or what if I did the skeleton format and I could even stick it off of this carbon here, an OH. That is also an alcohol, okay? The alcohol functional group is just coming off of carbon number 4 instead of carbon number 5 like the first one that I drew, okay? And if you notice, I'm getting more and more simple. I did not draw my lone pairs on the oxygen here in this last example, okay? So it's really important for you to recognize that. Let's make it another more complex one, okay? So same thing, let's just draw a few, and actually I'll go back to the blue. Let's just draw 4 carbons, okay? I'm going to draw the hydrogens out on this guy, so it's still an organic hydrocarbon, but now we're adding some kind of functional group. And I'm just adding them on the right because there's white space on the right, okay? Let's make it something that's a little bit, we'll say uglier, scarier, okay? So this functional group, we're going to have a double bond to an oxygen, and then we're going to have a hydrogen. Okay? My carbons, I'll number my carbons here. So this fourth carbon has 4 bonds. Okay? He's happy, he's got his octet, and we have a hydrogen as well as the corresponding double bonded oxygen. Okay? This functional group is an aldehyde. Okay? That's an E at the very, very end, is an aldehyde. So you need to recognize that because there's going to be another functional group that actually is a double bond oxygen, regardless of whatever the rest of it is. Okay? I'll just put a big old X on the left here. And it's actually going to be what looks like the alcohol. Okay? And that has a different name. That is a carboxylic acid. Okay? So we'll go through them on the slides. We'll go through them and examples of them, okay? But do you see how it can get a little bit difficult because you might first look at this one on the bottom and see the OH and think, oh, it's an alcohol. But you need to look at the whole picture and say, oh no, I have an OH group as well as a carbon with a double bond to an oxygen, okay? And this entire group on the right is a carboxylic acid, which is sometimes called a carbox, and then it ends in a carboxylate. Okay, so sometimes it's carboxylic acid, and sometimes it's just called carboxylate if you were to look it up online or something. Okay, so that's just what functional groups are, and you're going to need to memorize them and memorize what they look like and be able to recognize them. They're always going to be attached to some kind of, you can think of it some kind of hydrocarbon, an alkane, alkene, it doesn't matter, okay? One of the things you will also see, just to be super clear, is let's say I had a bunch of carbons, and we can go back to the alcohol that we did at the beginning, functional group, okay? If you're focusing on the alcohol component here, oftentimes chemists will say, I've got the alcohol, and you can even make my CH2, and then I'm going to make a big R for literally rest of molecule. That's what the R means, molecule. Okay? R for rest of molecule. So you will see sometimes if you were to look up functional groups, you look up the name of a functional group, they would say an alcohol would actually be R to OH. Okay? The R is going to be a carbon of some kind. So rest of molecule, you need to make a note, is going to be carbon of some kind. Okay? But we don't care what it is because it's an organic carbon. It's got so many hydrogens on it, that kind of thing. We're focusing on the alcohol component. Okay? So let's go to the PowerPoint slides and define, okay, define our functional groups, okay? So we saw in the previous video methane, ethane, hexane, just general hydrocarbons. Just to be clear, a lot of them are hydrophobic, okay, because carbon-hydrogen bond is non-polar covalent bond. But chemical properties of organic substances are determined by the functional groups, which is, you've now seen a few, they contain more than carbon and hydrogen, okay? They can have carbon and hydrogen, but they could have oxygen, they could have nitrogen, they could have sulfur, okay? And really, chemists differentiate different types of organic molecules based on functional groups, okay? So even people that work at the World of Coke in Atlanta will do this if they're trying to develop a new Coke that wants to taste a certain way and smell a certain way. A certain smell might be with the aldehyde functional group, and so they may be working with a variety of aldehydes to get the best smell for when you open your soda and you want to drink it, okay? So I already introduced functional groups. I was going to draw some of that, but what you're thinking of is in order to memorize, you're thinking I've got a hydrocarbon, and then I'm adding some kind of, we could do the double bond oxygen to hydrogen here, and this would be the aldehyde, okay? So that's what you're thinking of when you're starting to memorize them, okay? To re-emphasize, There's going to be some feature that is defined as a functional group. They will behave in a predictable way, okay? It's going to be a group of atoms that you need to recognize, okay? And we're essentially just replacing the hydrogen from an alkane or an alkene, okay? And that is, functional groups are how organic chemists classify the different molecules, okay? So real quick, the handout online that I told you to print out and have in front of you has two tables. This first table, if you see, the name on the left is an alkane. Then it has the functional group actually with just some bonds coming off. Doesn't matter what those bonds go to, they go to the rest of the molecule. And then they have sort of the general format with that R, that rest of chain, okay? The first three are the alkane, the alkene, the alkyne that we already had talked about, okay, the hydrocarbons. And there's the alcohol. So you can see it's carbon with an OH or R with an OH, okay? So the functional group is kind of shown in different color on this table, and I like this table because carboxylic acid, the only one that is actually can act as an acid, is shown in pink, and nitrogen is in the amine is shown in blue because it can act as a base, and everything else just contains normal polar covalent bonds, okay? The table from your textbook contains more detail. It even includes what chapter. So here's a functional group, ether. It includes that ethers are discussed in chapter 14 in the Timberlake book, if you want to know about ethers, okay? But it also shows on the far right, like the skeleton line structure of an ether, as well as some of the naming. So alcohols, like ethanol, instead of ethane, you'd say ethanol, and it shows here that you would end with an OL in the name. So this actually shows the aromatics and several more on here than are on the first table, okay? So the first table is a little bit more easy to read, but the second table is the one that came from your book, and you're going to definitely want to be memorizing the functional groups. If you prefer the R format or if you prefer this format, whichever way, you need to recognize these in a larger structure, okay? So once again, this is the table from your textbook that shows several examples, okay? And the examples may help you. So if you see, for example, that ester has carbon double bonded to an oxygen, and then another oxygen, and then another carbon, and then it actually shows an example that's in the sort of condensed format, and then a line structure format, okay? So a lot more examples from the table in your book, whereas this table just shows you the functional groups and defines them for you, okay? So this slide shows 3 functional groups. We already saw the alcohol, but essentially you may hear it called a hydroxyl group, okay? And this is ethanol over here on the right. You can see 2 black carbons and then the OH on the upper portion, okay? And the corresponding white spheres are the hydrogens. A thiol looks just like an alcohol, except instead of an oxygen, we have a sulfur, okay? So thiol, these are actually sulfurs smell really, really bad, sulfur groups. So sometimes organic chemists have to work with really smelly stuff, and they'll work with it in the hood so they don't have to smell it. Ether has an oxygen in between 2 carbons. So ether, the easiest way to memorize it is just COC, okay? Sometimes you may see it as ROR. There's no other appendages, no other elements to memorize, okay? It's just an oxygen in the middle of 2 carbons by itself, okay? Make a note that ether, how ether is spelled, because you're going to want to know how these guys are spelled. So ETHER, no S in there, no extra E at the end, no I, none of that, okay? So make a note for how it's spelled, okay? I say that because some of the other functional groups have similar names. There's a functional group that's ester that is spelled E-S-T-E-R, and that doesn't have an H in it, whereas ether does have an H in it, okay? Here are 2 more functional groups. The aldehyde we've already seen. So carbon double bonded to an oxygen, and that is got a hydrogen on it. So the aldehyde can be difficult because there are several different functional groups that contain this component here, where we've got carbon with a double bond to an oxygen. But if that carbon also contains the hydrogen, we're in aldehyde territory, okay? This bottom half is an example of the functional group that only contains carbon double bonded to an oxygen, which is called a ketone functional group, and you may hear it called a carbonyl group. Those two terms are used interchangeably. Organic chemists often say ketone, and biochemists often say carbonyl, okay? But they are the same thing. The only functional group that you're focusing on is the carbon double bonded to the oxygen. If there's no other, for example, the hydrogen for the aldehyde, or no other component, no extra oxygens anywhere, then you're just in ketone functional group territory, okay? Here's the carboxylic acid that I talked about already, okay? And we have the ketone group, but we also have the hydroxyl component that you saw with the alcohol. So you put them together, and all four of those elements, the hydrogen, oxygen, carbon, oxygen, all four of those elements attached in that format are the carboxylic acid group, which is sometimes abbreviated carboxyl group. Okay, you may see that if you were to Google examples of that. This is also in the shorthand. How would that be abbreviated? So if I had like 3 carbons, and instead of drawing it all out with my hydrogens, okay, if I wanted to draw it condensed, I'll draw it at the top here. If I wanted to draw it condensed, I might say CH3, CH2, COOH, okay? And that would be the same thing as this that I drew in the very center of the slide. So COOH is a little deceiving because it looks like the oxygens are connected, but they're not. They just, the COOH is often an abbreviation for carboxylic acid, okay? Ester also contains that ketone component, but if you see, the carbon is connected to an oxygen, okay, that is bound to another carbon, okay? So sometimes you might see R, C, O to R. You might see it written like that, okay? And that's the ester. No H in that name. Check your spelling. So it also contains the ketone, or the carboxyl group, okay, the carbonyl group, excuse me. It is often abbreviated like this, COOCH3, if, for example, this was CH3, okay? I mention that because organic substances use these kind of abbreviations when you're doing shorthand condensed formulas, okay? All right, amines are the next functional group I want to dwell on because amines actually have a couple different stages or levels. So they start with nitrogen in the center, and you've already seen an amine without carbon when you've seen this, which is ammonia, okay? So take one of those hydrogens and just make it, for example, CH3. We're still have an amine. Take a second hydrogen and make it also CH3. We still have an amine. It's still a functional group that contains nitrogen, okay? So that's what's at the bottom here. One of the hydrogens of amine, the lone pair is not even on these structures at the bottom, okay? One of the hydrogens became a CH3. 2 of the hydrogens in the middle guy became a CH3, and all 3 hydrogens are now CH3 groups, okay? So you may hear these listed as primary amine, secondary amine, or tertiary amine. And what that really means, primary is sometimes abbreviated like 1 degree, 2 degree, 3 degree. It just means that of the 3 bonds, and remember nitrogen has a bonding pattern of 1 lone pair and 3 bonds, the tertiary means of the 3 bonds, all 3 components are carbon groups, whereas in the primary, only 1 of the 3 bonds is a carbon, okay? So if you go back to the table that you need to know, Here's the amine, and it just shows it with one carbon and then nitrogen with 2 lines. But this top example on the right is a primary amine, and then the second example is a secondary amine, and the last example, the nitrogen is connected to all carbons. That is a tertiary amine. So that's why we have all 3. You would just need to recognize it, whether there were more hydrogens or more carbons present. Okay? So we are almost done going through the different functional groups. Okay? And you can see the pattern. They're just a different element. There's not very many of them, but we can come up with a lot of different combinations as we start combining functional groups. Okay? The amide functional group is actually seen in a lot of biological substances. Okay, so if you continue on and do more biological things, maybe in your regular biology class or microbiology, you would see the amide. Okay, you're gonna have this carbon double bonded to the oxygen, but that carbon is also bound to a nitrogen. Okay, and don't confuse amide because it's spelled very similarly to amine. So the only difference is an N or a D, but the amide has nitrogen plus this extra component. Okay, the simplest amide out there is urea. Okay, and urea is what if your body breaks down protein that you eat, urea is what's coming out in the urea cycle, if you ever had to learn that in a biology class. Okay, so that there is an amide functional group. Okay, you see amide functional groups in proteins all the time. Okay, so they're very common in biological substances. Okay, so the tables, just to recap, the tables here, this table goes through every functional group that we already went through, except this table here that is more simple does not have the thiol on it, but it shows the alcohol, the ether, the ester, carboxylic acid, ketone, amine, and it ends at the bottom with amides. Okay, whereas this one shows alkane at the top, alkene, alkyne, and then it actually shows the aromatic, including some double bond options. So there's aromatic, looks kind of funky, but it has all the appropriate hydrogens. That's actually benzene, if you've heard of benzene. It's common in organic chemistry. This even shows halides, the group 7, okay, where you could, instead of having a hydrogen, replace a Cl or a chlorine or something else from group 7. Okay, it's just an X here. And then the ones we've already seen, alcohol, ether, amine, aldehyde, ketone. These are all ones we've already gone through. You don't need to know the anhydride for me, but it's actually a really cool looking group. If you look on the right, it's a really neat group. Okay, but the ester, the amide, the thiol, I already went through with you. Okay, so there's a few extra on here, like the anhydride, that you don't need to know for me. You definitely need to know these for me. Okay, and you're gonna, if you're continuing on to 1152, you're gonna need to know them all anyway, so you might as well get them memorized. You just don't need to have, like on this table, the exact examples memorized. Okay, so memorize your functional groups. All right, know what components are in them, know what they look like, be able to recognize them, that kind of thing. Okay, and thank you for listening.